The next statement that we have is biconditional statements. A biconditional statement combines the original statement and the converse. Biconditional statements usually contain the phrase if and only if. Note that a good biconditional statement is when the original and the converse are both true. Good biconditional statements are definitions, and definitions are good biconditional statements. Let's take a look at an example here. Using this one, right? Given the statement, write its converse. If the converse is also true, combine the statements into a biconditional statement. So, if a number is divisible by 2, then the number is even. The converse, so Q, then P, is if the number is even, then a number is divisible by 2. Turns out that's true. So, the shorthand for a biconditional statement looks like this. It's an arrow going both ways. So the biconditional can be written as a number is divisible by 2 if and only if the number is even. Let's take a look at the next example. If x is greater than 5, then the absolute value of x is greater than 5. That's actually, let's take a look at this converse here. So if the absolute value of x is greater than 5, then x is greater than 5. Turns out that's false. All right, here's my counterexample. Let's choose negative 10. So absolute value of negative 10, that's true, that's greater than 5, but negative 10 is not greater than 5. So we have what we call a contradiction here. Next example. Is this a good definition? Explain. So we got a cat is an animal with whiskers. So we have to think about what is the converse, right? We have to think about what's the converse. So a cat is an animal with whiskers. So if it's a cat, then it has whiskers. If it has whiskers, then it's a cat. If it has whiskers, then it is a cat. That's actually false, right? Because I can think of a lot of animals with whiskers that are not cats. All right, let's think of one. First one that comes to mind is a seal. So a seal has whiskers and is not a cat, right? So that's a bad definition. Bad definition. Let's see. Second one. A rectangle is a quadrilateral with 4 congruent angles. So if the quadrilateral is a rectangle, then it has 4 congruent angles. The converse of that would be something like if a quadrilateral has 4 congruent angles, then it is a rectangle. That's the converse. That appears true to me, so this is a good definition. All right, last example, or last two. Write each statement as a biconditional. So points in the quadrant have 2 negative coordinates. If it helps sometimes, change it into an if-then statement, or try to break it apart into like a P and a Q, a hypothesis and a conclusion. So I've got points in quadrant 3 and have 2 negative coordinates. So I've got, as my biconditional, a point in quadrant 3 and then in green I have 2 negative coordinates. So if and only if I'm going to color code this properly. If and only if a point has 2 negative coordinates. Last one, a hexagon is a 6-sided polygon. Again, remember it's where the verb is, usually splits it up. So we've got a polygon is a hexagon. A polygon has 6 sides. So a polygon is a hexagon. If and only if a polygon is 6-sided. And that concludes our lesson.